In this video, we're going to learn about waves and 4 of their properties. Waves can be represented by a graph, such as this one. The first property we're going to talk about is wavelength, and we use the Greek symbol lambda to denote wavelength. The wavelength of a wave is the distance between its successive crests. We use the word crests to refer to these peaks on the graph. Since the wavelength is a measure of distance, we use units such as meters, millimeters, picometers, etc. In spectroscopy, the most common unit for wavelength is nanometers. Let's suppose this wave has a wavelength of 800 nanometers. Would the second wave have a wavelength greater than, smaller than, or equal to 800 nanometers? That's right. The wavelength of the second wave is smaller than 800 nanometers because its crests are closer together than in the first wave. Now let's move on to the next property, frequency. The frequency of a wave is the number of waves that pass a point in a certain period of time, usually a second, and we use the Greek symbol nu for frequency. Nu kind of looks like a cursive V. Since frequency is given by the number of waves, which has no units, over a period of time, usually in seconds, the units of frequency are usually given in 1/seconds, which is also called hertz, like the car rental company, but not at all like that. You are watching crests on a wave passing by a certain point, and you count 75 waves in 12 seconds. What is the frequency of the wave? That's right, there are 75 waves in 12 seconds, but we don't write waves. So that's 75 per 12 seconds, or 6.25 1/seconds, which is 6.3 hertz to the two significant figures in the problem. Your friend is watching a different wave, and they have a lot of patience. In 151 seconds, they count 895 waves. Whose wave has the higher frequency? Your friend counts 895 per 151 seconds, which gives a frequency of 5.93 hertz, so your wave has the highest frequency. Now that we know about frequency and wavelength, we can derive another property of waves, their speed. The speed of a wave is calculated by multiplying the wavelength in meters and frequency in per second. If the waves with frequency 6.3 Hz that you were looking at had a wavelength of 0.52 meters, what is the speed of the wave? That's right. Speed is the product of wavelength and frequency. So 0.52 meters times 6.3 per second gives 3.3 meters per second. Now let's move on to the last property we will learn in this video. Amplitude. The amplitude of a wave is the distance between the peak or trough of the wave and the equilibrium position, the horizontal axis. That means the higher the crest, the bigger the amplitude of the wave. Which of these waves has the largest amplitude? Exactly. Wave number 3 has the largest amplitude because its crests are the highest.